Now we get to write a program. It's programming time. I've been working on a magic trick tonight to write WebAssembly from scratch. And so WebAssembly is this high level for assembly, but pretty low level language that you're not supposed to write from scratch. And that's what makes it cool. Anybody who can look at a binary and make changes to it, that's just wizardry to me. That would be a great, I don't know, it'd be a great gag at least. A year or two or three, I think before the pandemic, 2.5 years ago, I did this. I tried to do a few days of Advent of Code in WebAssembly, and I was trying to write it from scratch. So this is where I started, and basically it's the ability to write these bytes. I've explained these bytes. I understand them. I used some reference materials. The best reference material I think was this one, this WebAssembly design blob main binary encoding.md. This is, if you want to do this is the one you need. I did some studying. I made a little list. Stupid trick. Went through these steps. Anyway, let's call it scratch.mjs. And at the bottom, you do get good error messages if you try to run this. So I'll say entr. Oh, cool. So I'm going to write some code, and then I'm going to take that code and do a, what is it? Let's make const array equals a u int 8 array from the code. Let's get a module from WebAssembly dot compile the array. That returns a promise. And then let's instantiate the module, and then instance.exports. Whatever we want to call it. I'll call it ABC equals, or that is a function. Let's call it console.log of that. Cool. So now I've got to write some code. WebAssembly code, the binary format for it, starts with a magic, what do we call these? Not a magic word, several magic bytes, not just one magic byte, but a magic number, that's what we call them. And that magic number is 0, 97, 115, 109. Then we have the version of WebAssembly that this is. If you want to look at this up properly, you can go to, like, again, that, like, here's a nice little diagram, but you can read the whole thing in here. Anyway, we start with, right, our version number 0001, but it's little endian, so we put the 1 over here. And then we have some sections. The sections we're going to have are a type section. That's going to have a 0, a 1 here, I think. We'll have a function section. That's 3, maybe. We need a code section. An exports section, which is going to be section 7. And we need a code section, which is 10. In each of these sections, we're going to have a number which is the length of the rest of the bytes in the section. Who knows what that's going to be yet? Eventually, it'd be cool to just memorize those two, but we don't know what those will be yet. The type section, we are going to have one type in this. And so here you put the length of it. Now we say, I have one type. That type is, shoot, and there are 4 magic numbers that I need to remember for this. And I think this one is 0x40, which describes a function. We have to say how many arguments it takes, 0, how many return values, 1, and then a magic number describing an int 32, and it's something like 7 7f. I think it's 7f. We'll see in our error messages if these are right. What next? Okay, now I know the length of this. Looks like it's 5, right? There are 5 bytes. 1, 2, 3, 4, 5. The function section, I don't know how long it is, but I have one function. That function is, how does this work? I think I've just memorized this one. It's 3210, and that's because it's the rest of it is 2 bytes. It's 1 because there's one function, and it is the 0 index into the type section. Then we have exports. Don't know what the length is. The export we want, let's have one export. It is of length 3, and I said it was ABC down here, so we can build ABC with the bytes. I could just say A if it were, but doing it with numbers, 65, 66, 67 should be ABC. And then what else do we need? We need to say that this is a function, which happens to, you specify 0, and then this is function at index 0 of the function section. Looks like this is 1, 2, 3, 4, 5, 6, 7 bytes. About ready for the code. This is the length of the entire code section. There is one function here. The length of that function is also don't know. This is don't know plus 2. Let's write some code. We start with the number of local variables we'll need, 0. Then this is bytecode, push something onto the stack. The thing I want to push on the stack is a constant. It is, what was our magic number for constants? 0x, oh, I'm getting it from autocomplete, because it's, no, it's not either of these, it's a different one. It is 41, maybe 61, I don't know. Oof. I feel like it's 61. I don't know. And then maybe it was, I think maybe it was 41. Gosh, I don't remember. Yeah, let's add the numbers. Now we get to write a program. It's programming time. So I'm going to add the number 5 and 0x41. Let's add that to the number 7. And then, well, right now I'm not adding them. I'm just pushing these two onto the stack. And now let's add those two things. How do you add? I think it's 0x60 6a, I think. So add is 6a, subtract is 6b, multiply is 6c, and the two kinds of division are the next two. That's our program. We end it with a special byte. That's none of these. It is, maybe it's 7b. No, it's 0b. Cool. And now we look at the length of this. It's 1, 2, 3, 4, 5, 6, 7. Oh, great. And now we start getting good error messages. Expected signature definition 0x60, but got 40. So this 40 was supposed to be a 60. Okay, that's interesting. What else? ABC is not a function. Great. Why not? I think I wrote ABC here. Oh, those are capital ABC. ABC. Great, we did it. So I need a little work on some of these, but we didn't look anything up. Great. Sorry, there's no shared responsibility, shared claim here. I didn't look anything up. Feeling good about it. It'd be fun to do this in some, I don't know what context, but you know, live code this at a conference or something in some comedic timing thing. And since no one watches my YouTube channel, it'll still be a secret. It'll be great. Don't tell anyone.